Okay, so welcome to this lesson on sequences and series. So I've decided to do this because a lot of you do struggle with sequences and series and understanding what theorem to use when and so on and so forth. So we're just going to go through a couple of theory and then some practice and the type of questions that you might be asked. So with sequences and series, in grade 11, you were introduced to the quadratic series. So it's really important that you revise that and you understand how to use that. It's very easy marks to get. In grade 12, we mainly focus on the arithmetic sequences and series and then the geometric. Let's actually use a different color. Let's be fancy. So geometric sequences and series. Okay, so if we start with the arithmetic sequences and series, that's when I'm talking about a common first difference. Okay, so your common first difference is your arithmetic, so that's where you plus 2 every time or minus 3 every time. So there's a common first difference, and it's very easy to see just right off the bat by looking at a sequence. And your quadratic is where you've got that common second difference. So your arithmetic is common first difference. And the formula that we use is Tn, so that is your outcome, okay, the outcome of a term, a plus n minus 1d, where your a is your first term. Okay, so the result of your first term, the outcome of your first term, and D is that difference, that first difference that we speak about. And then you would solve it algebraically to find a nice general term. Then if I look at my geometric sequence, so that is when we've got a common ratio. Okay, it's very important to understand the difference between a difference and a ratio. Your difference is when you've added 2 every time, or added 3, or minus 5 every time. Common ratio is when you're multiplying by something, you're multiplying by a ratio, okay? So the formula that we use for the general term, so Tn, your outcome, is equal to A, so that's your first term, R to the power of n minus 1. Okay, where R is your ratio that you work out, and A is your first term, so the outcome of your first term. So it's really important to understand those formulas. Okay, so let's do just a few examples with each one before we move on to the next set. So if I say find the 10th term of the sequence 5, 12, 19. Okay, so right off the bat, they don't tell us if it's arithmetic or geometric. So you know it's arithmetic because I put it in the arithmetic section. But you have to establish whether you know if it's arithmetic, quadratic, or geometric, because then you can start using those theorems. So it's very easy. I'll do this in white. It's very easy to see that we've added 7 every time. So that's what I mean by constant first difference. I'm adding something constant every single time. Okay, so then immediately we know it's arithmetic. So your mind needs to go to that formula. So, and they say find the 10th term. To be able to find the 10th term, we need the formula. Okay, so if we find the term first, the general term, so a plus n minus 1d, so Tn is equal to my first term, which is 5, plus n minus 1, my difference is 7. So we're looking for the general term because then we can find out for any term number what the outcome will be, and that's where we want to go. So 5 plus 7n minus 7, and then we work it out algebraically. 5 minus 7 is negative 2, so this will be 7n minus 2. Okay. All right, so once we found they didn't ask for the general term, they obviously asked for the 10th term. Okay, so now we're going to say, okay, what is the outcome of the 10th term? So we're going to put 10 in to see what we get out. So this will be 70 minus 2, which will be 68. So if I go on and on with the sequence, so that's the first 3 terms, fourth term would be plus 7, and then so on. Once I get to the 10th term, my answer will be 68. So that's what they're asking for. Okay, let's do an example with our geometric. Okay, so if I say find the 6th term of the sequence, 2, 6, 18. Okay, so obviously they don't tell us it's geometric. So we need to find out what it is. So if I go 6 minus 2, it's going to give me 4. 18 minus 6, it gives me a completely different answer. So I don't have a constant first difference. Then I check if I have a constant second difference. Okay, so if I go 6 minus 2, that's going to give me, let me just change the color so that you know what I'm doing. Okay, so 6 minus 2 is 4. So I added 4 there. Then 18 minus 6 is 12. So add 12. Okay, and then they don't give me enough to see if there's a second difference. So let me try the ratio. So remember, to find the ratio, we have to divide the terms. So we go term 2 divide by term 1. That's going to give us our ratio. So 6 divided by 2, that's going to give me 3. Let me just check with the next one. So term 3 divided by term 2, that's going to give me my ratio, which is 18 divided by 6, which is also 3. So we can see that every single time I multiplied by 3, which means there's a common ratio. Okay, so then let's use our geometric sequence formula to find the general formula, and then we can find the 6th term by working with that. So Tn is equal to ARn minus 1. My A is my first term, which is 2. My R is 3n minus 1. So that is my general term. Very easy to find. Okay, so now they ask for the 6th term. So the outcome of the 6th term. Okay, so 6 minus 1. So that's going to be 2. 3 to the power of 6 minus 1 is 5. Please be very careful that you don't go 2 times 3. Remember that 3 has got an exponent, so the exponent takes preference. Okay, so you first need to work out the exponent, and then you can do what you need to do. Okay, so if I do that, so 2 times, I'm just getting my calculator. So you go 2 brackets 3 to the power of 5, and you get 486. So that means in my 6th term, I'm going to have an outcome of 486. Okay. All right. So let me see. And then obviously you can do examples of where they ask for the term number and so on and so forth. Okay, let's have a look at, sometimes they use simultaneous equations, or they give you 2 pieces of information and they don't give you the first term or the difference. So let's just have a look at this. So if we've got an example where it says determine the arithmetic sequence if the 4th term is negative 6 and 11th term is negative 34. So it's weird information, so I'm going to write it out for myself. Okay, let's do this in just the orange. Okay, so I know that the fourth term, so T4, is equal to negative 6, and they've told me that my 11th term is equal to negative 34. Okay, so let's write out what this means. Okay, so if I look at my formula, so always keep your formula in mind. They told me it was arithmetic. So I'm going to use, ooh, that looks ugly, sis. Okay, I'm going to use my arithmetic sequence formula, which is Tn is equal to a plus n minus 1 d. Okay, so with this fourth term here equals to negative 6, I know my outcome is negative 6. Okay, a I don't know, plus n is 4 minus 1 d. Okay, so negative 6 is equal to a plus, we do the bracket, which is 3d. So this is negative 6 is equal to 3d plus a, or the other way around. It doesn't matter. So we've got a formula for this one. Okay. All right. Let's look at our 11th term and put this into what we know. So negative 34 is my outcome. A I don't know. And then we've got the 11th term minus 1d. So negative 34 is equal to a plus 10d. Okay, that's my second. I've got two formulas there. Okay, I've got two equations with two unknowns. So I know I'm going to do a simultaneous equation. Okay, so let's do our simultaneous equation. So the first step, let's take an equation and isolate a variable. Okay, so if I go and I take equation 1 and I isolate a, so negative 6 equals 3d plus a. Let's isolate a. So I'm going to take the 3d to the other side, and that's a. So there's my third equation. Then I'm going to sub 3 into 2. So remember, I choose equation 2 because I've used equation 1. So negative 34 equals, and instead of a, okay, instead of a, I'm going to put negative 6 minus 3d instead. Okay, and then I've still got the rest of the equation, which is plus 10d. Okay, and now I'm just going to solve it algebraically. So this is negative 6 minus 3d plus 10d. Okay, let's move all my constants to one side and keep my variables on the other. So negative 34 plus 6, and then negative 3d plus 10d is just going to give me 7d. So 34 plus 6 is negative 28. Let's make sure. Yes, negative 28 equals 7d. Divide by 7 is going to give me a negative 4. So d is negative 4. Let's find a. Okay, so if we've got d, so let's do, I'm going to do it over here. So sub a into, let's do equation 3. So remember, you can sub in d, sorry. You can sub in d into any equation. I choose number 3 because you've already got a in isolation. So negative 6 minus 3, and instead of d, I'm going to put negative 4 equals a. So negative 6 plus 12 is equal to a, which is just going to give me 6. So now I know if I write this formula, let's use a different color so we can keep up. Okay, if I write this formula, so Tn is equal to a, which is 6, plus n minus 1, d, which is negative 4. Okay, so they asked us to determine the arithmetic sequence. So not the formula, the actual sequence. So if I go and put it into terms, so remember you've got term 1, term 2, term 3, term 4. Okay, usually 4 terms is enough. I would even say 3. So term 1 we know is 6. Okay, term 2, if we put 2 into this formula over here, So 6 plus 2 minus 1 times -4. So that's going to be 2. And then the next one, if you put into the formula, is -2. And this is what they're asking you. Okay. So that is how you do those questions. So always write what you know, what formulas you know will work with it, and so on and so forth. All right, let's do another example, but with geometric sequence. So determine okay, so determine the geometric sequence if the second term is 1/9 and the sixth term is 1/729. So let's have a look at this one. So tell yourself what you know. So I know that T2, let's do a different color. Let's use blue. So T2 is equal to 1/9. And I know that T6 is equal to 1/729. So what that means is with a geometric sequence, so I think of my geometric sequence formula, Tn is equal to AR n minus 1. What do I have and what do I need? So I know my outcome is 1/9 is equal to A, I don't know, R, I don't know, but I know my turn number is 2. So then this will be 1/9 is equal to, let's just make that 9, AR to the power of 1. Then T6, I know my outcome is 1/729. A, I don't know, R, I don't know, N is 6, so 6 minus 1 is going to be 5. So I've got two formulas here. Now you can go into an ugly simultaneous equation, or we can just take equation 2 divided by equation 1 and use our exponential laws. So if we take equation 2, so 1/729 is equal to AR to the power 5, and I divide it by, so both sides, I divide by number 1. So the result for 1 was 1/9, and we had AR to the power of 1. Okay, so if I put this into my calculator, so, and make sure that you've got your lines right in your calculator, 1/729 over 1/9. So, or you can just use the divide sign, which makes it easier. Okay, so we get 1/81 is equal to, now with our exponential laws, I know my A's cancel out, and then this I've got 5 minus 1. So R 5 minus 1 is just going to be R to the power of 4. Okay, and then obviously I'm going to just root the other side. So I'm going to root by 4, root 4, root 4, and that I get R is equal to, and because it's an even exponent, I know it's going to be plus minus 1/3. Okay, so we obviously have to do it if R is positive or if R is negative. Okay, so let's go have a look. So we're going to sub in, because obviously we need A, so let's just do it to the side here so that we've got everything. Okay, so if therefore R is equal to 1/3, or R is equal to negative 1/3. Okay, so let's have a look with our A. So if we put this into one of the equations to find A, so I've got 1/729 is equal to A, R is 1/3, and we've got to the power of 5. So if we do that, let me quickly work this out. So we're going to say 1 over 729 divided by a third to the power of 5. Okay, and I get 'A' is equal to 243 over 179. If I put in a negative a third, okay, I know, so if I put in a negative a third, then my A will be negative 243 over 179, okay? And then we would determine the sequence. So using just the formula, now that we've got A and D, I would get that if, so let me just get this right. So with my formula, so my formula is Tn is equal to A, which is 243 over 179, times R, which is a third. So remember, it can be negative a third or third, n minus 1. Okay, so then if I put my terms into that, so give me time to do that. 179. So if we put, obviously our first term is 243 over 179. Our second term, so if we put 2 minus 1, that's going to give me 81 over 179. My third term is going to be 27 over 179, and so on. And then you would do the same where R is negative a third. Okay, so for the sake of time, I'm going to just move on. All right. Okay, let's have a look at series. Okay, please make sure you understand the difference between the sequence and the series. So if my sequence is 1, 3, 5, 7, 9, okay, this is my sequence. Okay, my series is if I say I add all of these terms. Okay, so my outcomes are still the same. All I'm doing is adding them, and I call that a series. Okay, this will help is if, like, for instance, you say that you run an extra 2 kilometers a week. Okay, so you start with 2 kilometers, then the second week you run 4, and you add 2 every time, and then at the end you want to know what the total of kilometers you have run. So then that's why you would use your series, because you would add them all together. Okay, so if we look at our arithmetic series, right? Okay, so there's our formula for our arithmetic series is if we've got Sn, so sum of n over 2, 2a plus n minus 1d. So this is the formula if we want the result. So if I want 1 plus 2, 1 plus 3 plus 5 plus 7 plus 9, what is the answer for that? I can use this formula if I know the formula of this arithmetic series, okay, because it can go up into a really large number. Another formula that you can use is if given the last term, you can also find the sum of the series by saying n over 2 a plus l, where l is your last term. Okay, so be very careful. If they give you the last term, there's no reason to put it into all this because you don't know the term number. You can just use your last term. Okay, then if I look at my geometric series, so geometric right? Our geometric series we would use if there's a geometric series that we know and we want to know if we add all of them together, what is the sum of that sequence? So Sn is equal to a r to the power of n minus 1 over r minus 1, and this is if our ratio is greater than 1, okay? Then if your r is less than 1, we can just swap those around. 1 minus r to the power of n over 1 minus r. Okay, so be vigilant about what your r is, because it will make it easier to know which formula to use. All right. Okay, let's do some, and then just a quick thing with geometric series. So we speak about divergent and convergent geometric series. So divergent geometric series is when it goes up until, so if you add the terms, it goes up until a really high number. So let me give you, or a really low number, but there's no like end to it. I'm just trying to find a nice geometric series. So if you go, for instance, 1 plus 3 plus 9 and so on, your total, your sum of all of those is going to get even more. So 1 plus 3 is going to be 4, plus 9 is going to be 13, plus whatever, it's going to go up and up and up. So there's no end to it, okay? When you're looking at convergent, okay, convergent, it means it goes towards a certain number. So for instance, if you're looking at a tree that's growing and it grows by a certain ratio every year, eventually that, so with the first year it grows, let's say a meter, the second year it grows half a meter, a third year it grows even less and less and less, to the point where it stagnates. So it gets to a point, so it converges to a point. And how this looks on a graph is you've got your sequence that goes like this, okay? So it converges to a certain number, okay? If your series is divergent, your r is less than 1, or r is not less than 1, greater than 1, or less than -1. If your series is convergent, that means your r lies between 1 and -1. Your ratio, sorry, not your series. So your ratio, you're looking at your ratio. If it's divergent, the r is greater than 1, so you're talking about if your ratio is 2, 3, 4, 5, 6, and so on, and your r less than -1, so you're -2, -3, so on. If it's convergent, you're looking at those basically your fractions that lie between -1 and 1. Okay, so that is what you're looking at. So let me quickly just go through a bit of examples with determining the sum of. So let's have a look. So evaluate the sum of each of the following. So I'm going to do 20, 17 plus 14 up until 500 terms. So this is when you can't just put it into your calculator because it goes up to 500 terms. Okay, so it's easier for us to just use a formula, and that's why they developed those formulas. Okay, if we've got 1 plus 3 plus 9 up until 8 terms. Okay, so the fact that they've said sum of, you know you need to use your series formula because you're adding them. Okay, so if we look here, let's look at A. Let me first determine if it's an arithmetic series or a geometric series. So let me go 17, so T2, let's not divide, let's first check if it's arithmetic. T2 minus T1, which is 17 minus 20, that's going to give me a negative 3. If I go T3 minus T2, that's going to be 4 minus 17, okay, which is, let me just, oh, sorry, not 4, 14. I knew it didn't make sense. Okay, 14 minus 17, that's also negative 3. So I know it's an arithmetic series. All right, so I use my series formula. So Sn is equal to n over 2, 2a plus n minus 1d. Okay, so my Sn, so they're looking for the total. So if I add them all together, they're looking for that total. Okay, n, they said up until 500 terms. So 500 over 2. A is 20 plus n minus 1. Oh, we've got our n. N is 500 terms minus 1. And my d we worked out to be negative 3. Okay, so if I type that into my calculator, I'm going to get an answer of negative 364,250. All right. Okay, so that's for A, and they wanted the sum of those terms, so I have answered the question. Let's look at B. Okay, so 1 plus 3 plus 9. So let me see if I minus the terms, if there's a common difference. So 3 minus 1 is 2. 9 minus 3 is 6. So I don't have a common first difference. Let me see if I've got a ratio. So T2 over T1 is equal to 3 over 1, which is just 3. T3 over T2 is equal to 9 over 3, which is going to be 3. So I know my ratio is 3. Okay, so let's use my geometric series formula, so which is your is equal to, and I need to establish, is my r greater than 1 or is it less than 1? So my r is greater than 1, so I'm going to use the formula that says a rn minus 1 over r minus 1. So my a is 1, r is 3 to the power of n, which is 8 terms, minus 1 over r is 3 minus 1. And if I put that into my calculator, I'm going to end up with 3,280. So I know if I go 1 plus 3 plus 9 and I go all the way up to the 8th term, if I add them all together, it's 3,280. So it's very different from a sequence to a series. I'm not asking for the 8th term. I'm asking for the sum of the 8 terms. So I'm adding 8 terms together. All right. Let me quickly find one where they ask for R to be, if it's what it needs to be convergent or divergent. Okay. 1 second. I just want to get a nice one. Okay, so let's do one of these. So okay, so we're doing diverge. Okay, so let's have a look. If I say determine the value of x for which the series would converge, okay, given 3 plus 3 times x plus 1 plus 3x plus 1 squared. Okay, so if I am asking for which the series will converge, I know that it will converge if r is between -1 and 1. So I need to determine what my r is, okay? But to get my r, I know I need to go term 2 divided by term 1. So term 2 is 3 over x plus 1, and t1 is 3. So then my r will be x plus 1. Okay, I know my r needs to be between -1 and 1. So let's say -1. So I know x plus 1 needs to lie between -1 and 1. And I solve this like a normal inequality. So the 1 goes, we minus 1 from both sides to get rid of that 1 in the middle. So this will be -2 and 0. So x will have to lie between -2 and 0. These are very important. They like to ask these. So please make sure that you understand. Okay, I'm going to quickly do some sigma notation. Okay, and then I will do the sum into infinity for geometric patterns. All right, so sigma notation, we've got this sign here, which is sigma, which basically means the sum of. So immediately when you see sigma notation, you know you need to use Sn is equal to n over 2. So this is our arithmetic sum of arithmetic series. So 2a plus n minus 1d, and our geometric is either going to be Sn is equal to a r n minus 1 over r minus 1, or the other way around. So you need to make sure with sigma notation, you are looking for the sum of terms, okay? So if I've got, for sigma notation, it looks a bit like this. So k, maybe k is equal to 1. And we've got our formula here. This n tells me my last term number. Okay, not my last term, my last term number. So if I give you a series and I go 2, 4, 6, 8, 12, and I end there, okay? This is term 1, term 2, term 3, term 4, term 5. This n will be my last term number, so 5. It won't be 12. It's not telling me my last term. It's telling me my last term number, okay? So just important to know the difference. This tells you the first term number. And then whatever after the sigma notation is your formula. So it tells you what kind of series we're looking at. So for example, if I say evaluate r minus 1, and my formula 3 plus r minus 1, 3 over 2. Okay, I have a look at that. 13 is going to be my last term number. 1 is going to be my first term number. So I know this sequence starts at term 1. So if I say evaluate it, I want the sum of those terms up until the 13th term. Okay, but I first need to expand when I get a sigma notation question. So let's expand. So my first term, so I go 3 plus r is my term number in this case. So I know it starts at 1. So let me use a different color. So 1. minus 1 times 3 over 2. Okay, so my first term will be 3. My second term is 2. And that will be 9 over 2. And then the third one is going to be 6. Okay, so I expanded and I know it's going to be 3, 9 over 2, 6, and so on. But remember, it's a series. So I'm looking at 3 plus 9 over 2 plus 6, and so on, up until my 13th term. Now, because they tell me what my last term is, I can find out what my 13th term is for my last number. So 13 minus 1, 3 over 2. So that's going to give me 21. Okay, so now let me find out. I need my sum of this series. All right, so I can see that this is going to be the one where I use the formula with where I have my last term. So it's going to be n a plus l over 2. Okay, so let's have a look at what that means. So Sn, I'm looking at the sum of until the 13th term. So the n will be 13. A we've said is 3 plus my last term, which is 21 over 2. I'm so sorry about that. Okay, so that will be 156. So it will add up to 156. Okay, let's quickly look at if they want n. So they say to us, determine the value of n if okay, so I'm just going to quickly move to plug in my battery. Okay. All right, so let's have a look at this. So basically what they're asking me for is this n. So the last term, they've given me the answer. So they're saying if I add up all the parts of the sequence, I'm going to get 381 until the last term. Okay, so let's find out now what our n is. So I know I first need to establish, is this an arithmetic sequence or is it a geometric? I can clearly see it's geometric because of my formula. All right, so I'm going to use my geometric sequence, a series formula. All right, but I'm first going to work out what is R and what is A. Okay, so what is A? If I look at my formula, I can see that it's 3. What is R? If I look at my formula, I can see it is 2. Okay, so then let's use my formula. So Sn is equal to, I established that my R is greater than 1. So I'm going to use the one where we've got A Rn minus 1 over R minus 1. Okay, so my A is 3. My R is 2. N is what I'm looking for, minus 1 over R is 2 minus 1. So this is going to be 3 times 2 n minus 1 over 1. So it's just that. And we know my answer, sorry, my answer is going to be 381. Okay, in the end, this is going to be my answer. So now we're going to solve for n. So I divide both sides by 3. Okay, so that is going to be 127 is equal to 2n minus 1. I'm going to add 1 to both sides. 128 is equal to 2 to the power of n. All right, and then I'm going to use either my logs, or I know that this is going to be 2 to the power of 7. So then n is equal to 7. So that means my last term is 7. Okay, so if I add up all the numbers of the sequence up until the 7th term, I'm going to get an answer of 381. Okay. All right. Let me look at sum to infinity, and then we are done. Okay, let's use so sum to infinity we use with our geometric sequences, and we do this to find out basically what numbers, in order to determine the sum to infinity of a geometric sequence, we use a formula so that we can see what it converges to, or and so on and so forth. So there's many uses for it, but the formula that we use is sum into infinity is equal to a over 1 minus r, where your a is your first term and your r is your ratio. And obviously, when we do sum to infinity, we're looking at what number geometric sequence a series converges to. So we're looking at where my r lies between -1 and 1. Okay, so if I look here, let me quickly get an example for us. Okay, so let's say determine so let's do A, we do 5, we do an easy one. So what number this series will converge to. Okay, and then B, we can do maybe a sigma notation. Okay, so let's do these. Okay, so A, all right, so determine the sum of each of the following. Okay, so let me use my sum to infinity. So if I go, I can see that if I have 5 plus 5 over 2 plus 5 over 4, let me determine my ratio. So my r is going to be, if I go t2 over t1, so that is 5 over 2 divided by 5. Okay, so that will just give me a half. Okay, so that's my r. Okay, my a is equal to 5. All right, so if I look here, my sum to infinity, because my r is a half, I know it lies between -1 and 1, so I know it's going to be convergent. So I can use the sum to infinity because it's going to give me the sum of all the terms up into infinity, and it's going to converge to a certain number. So s to infinity is equal to a over 1 minus r. So s to infinity, so sum to infinity is equal to 5 over 1 minus a half. Okay, and if we put that into our calculators, I'm going to give you a minute to find mine. Okay, so 5 over 1 minus a half. That's going to give me 10. So I know that this geometric series will converge to the number 10. Okay, so it will end up being equal to 10. Let's do our sigma notation. So let me quickly, and then after this,